To install Python, you'd go to the Python website, www.python.org. This is the place to start for information on Python. So if we're interested in installing Python, you go to the Downloads tab, and there you'll see that there are Python installations available for Windows, for the Mac, and also for Linux under other platforms here. You'll also see different versions of Python available, so which version should you use? Well, in a nutshell, Python 2 is now history, it's obsolescent, and Python 3 is the current version, so Python 3 is now and is the future. So there's no doubt in my mind that if you're starting off with Python today, you should be focusing on Python 3, and all of the Python examples you see in this webinar will be using Python 3 code. Nonetheless, it's important to know that there are significant differences between Python 2 and Python 3, and the two versions of Python are not totally compatible with each other. So many of you will find that there is Python legacy code still in use in your organisation written in Python 2, and that Python 2 code will not run under Python 3 and vice versa. So it's very important to know which particular version of Python you're using. So when you install Python, if you're under Windows, you'll see various new items appearing on the Start menu. Here I've got both Python 2.7 and Python 3.5 installed on the same machine. Python runs in a shell. The Python shell is described here as Python 3.5. There's also a bunch of manuals and documentation as part of the installation. More typically, rather than just running Python in a raw shell, you'll run Python using idle, and idle is the interactive development environment that's built into the Python installation. So typically under Windows, we click on idle to start Python running, and here we can see the idle Python shell running. If you're on Linux, then you can start idle from the command line. And this particular Linux installation, I already had Python 2 pre-installed, so I chose to install Python 3 by hand on top of Python 2. And then in order to start idle, I typed idle 3 from a Linux terminal, and that started the Python 3.5 shell running under idle. So let's take a look at running Python in a shell. As I alluded to earlier, you can actually type Python commands interactively in the Python shell and have those Python commands run immediately. So let's do some of that. So here we've just typed 2 plus 2 into the Python shell, and you can see that Python has immediately returned the value of 4. So you can effectively use Python as a glorified calculator, although that's not a particularly important application of Python. Let's try some more things. So here we've assigned a couple of variables. We've written a equals 2, b equals 3, and then typed in a times b, and the value of 2 times 3, 6, has been printed out in the shell. I'll talk you through what's happening here in a little bit more detail because it's quite instructive. In Python, all values are objects in the object-oriented programming sense. So if you just type 2 in at the Python command line, you're actually having Python create an object for you, and that object is an integer with a value 2. By writing a equals 2, what we're then doing is binding that object to a Python variable. So Python variables like a and b are not declared as such, rather variables come into existence when you make assignments to those variables for the first time. So here we've got two different variables a and b bound to two different Python objects, 2 and 3. We've then multiplied the values of those two variables together, which will have the effect of multiplying together the two objects, and the new value 6 is a third object, and an implicit method of that object is being called to give a value that's printed out in the Python shell here, 6. Of course, we can do lots of other things at the Python shell. So here we've got a hello world program executed from the Python shell. This is calling the built-in function print with the string hello world, which will simply echo hello world in the shell. You can also write control flow constructs interactively in the Python shell. Maybe not something that you typically want to do, but you can. So here's a for loop being executed interactively. So here we're saying for I is a new variable, in range 4, print out the value of I. And that's going to print out the values 0, 1, 2 and 3 as shown here. So the range syntax is actually going to return 4 values, the values 0, 1, 2 and 3. The loop variable I will get each of those values in turn, and we're then printing out the values of each of those values to the Python shell. From the Python shell, you can also launch the idle editor, and the idle editor is a fairly neat development environment for Python code. It might not be directly comparable to the sort of fully featured IDEs you might be used to, but it's certainly perfectly capable for developing small Python programs. So here goes. We can start the idle editor from the file menu of the Python shell, for example. So here's a fairly conventional file menu, giving us the ability to open existing files or create new files, which will be opened in the Python editor. If you happen to have a Python file already in existence, and Python files always have the file extension .py, then for Windows you could start that from a pop-up menu. So here we can select Edit with Idle, again to open this file in the idle editor. And here is the idle editor. So it's like any text editor, it's Python sensitive, so the menus here contain commands that are unique to Python. So here, for example, we can use the format menu to indent and dedent areas of Python code or comment regions. The run menu is the one you probably use most for executing Python code, and in particular it's handy to know about F5. So if you bang the F5 key within the idle editor, that will immediately run the Python program shown in the editor. And if we haven't yet saved the program, we'll be prompted to save the program, and the program will then go ahead and run in the corresponding Python shell. And here you can see the output from the Python program. So let's take a look at this 4-line Python program in a bit more detail. So we're creating a new integer object 2, binding that to the variable n. This is the first mention of the variable n. Then we've got a for loop, so this variable I here is taking values in the range 0 through to 7. We've then got the colon, and the colon marks the start of the statements that are executed within this for loop. And what you typically do then is start a new line and type 4 spaces. So control structures in Python are shown using indentation, and one level of indentation is always at least 4 spaces. So you should always get into the practice of using exactly 4 spaces to indicate one level of indentation to show when you're nesting Python code inside other code. That's very important. Then inside the loop we're executing 2 statements. We're multiplying n by itself and putting that back into n again, and then printed out its value. So if we jump down into the Python shell, we can see the values printed out. 2 times 2 is 4, then 16, then 2, 5, 6 and so on. And hey, look, these numbers are getting pretty big. In fact, it turns out that in Python, there's no built-in upper limit to the maximum value of an integer. So integers in Python can grow as big as they need to grow. So here you've got some pretty phenomenally big integers being generated just through this simple 4-line for loop. So here we're running Python code from the idle editor and having that Python code then run in the Python shell, again within idle. And if you explore these menus here, you'll find there's a full interactive source code debugger available within this idle environment, so I'd encourage you to explore it. You can also run Python programs more conventionally from the command line. So jumping into a Linux terminal window here, you can see we've got a file spam.py that contains the 4-line program that I've just shown you. And we can then execute that program by typing python spam.py. So you can run Python programs from the command line just like you can run C programs from the command line using GCC. And you can see the output from the program being printed out here in the shell window.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of John's webinar, Python in 1 hour, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.